So when you talk of cyber security, there are some industry standards, guidelines, best practices, procedures, right? So NIST is one of the organization, globally, they provide these frameworks. It's called National Institute of Standards and Technologies. They give you a lot of frameworks. Using that, when you adopt these standards, it will help you to minimize the risks, right? So how does the cybersecurity framework of NIST work is? The first step is to identify what are the assets that you have. It could be servers, applications, employees, everything. Understand the business environment. What is the governance requirement? What is the, like I said, SOX control, HIPAA, all those components. What is it that from the governance perspective you need to do that? What are the risks associated with these assets, right? It could be natural risks, right? Earthquake. Is my organization, is my data center of my organization is located in the location which is prone to earthquakes, right? Or fire, or any other calamities. So you do all this risk assessment. What are the threats that my applications and servers could encounter, and then what is my risk management strategy? So the first step of NIST cybersecurity is to identify these things. The second one is to, how do I protect? Okay, I have my systems. I have understood what are the risks of all these things. How should my how should I have my access control in place? How far I control awareness and training? How often do I provide these things? What are the data security requirements? How do I do that? How do I protect my systems? Information policies, procedures, and technologies that I use. Okay. The other one is, like I said, detect. It's not about doing the assessment, put some protective measures. It's about detecting. It is a constant process. Like I said, it's a continuous process. So you have to find out the anomalies. What are the events? Like I said, security incident event monitoring. So this is a rep. It's more of a hygiene. We talked about cyber hygiene, right? And what are the detection process that I have? Then how do I respond? If there is an incident happening, if there is a ransomware attack, what will be my response plan? Okay, will I restore my systems from my backup systems? Will I point the application to my other systems in other region? So this is more about how do I respond to any of these things? How do I communicate? Okay, now we talked about compliances and regulations, right? It is even in India, the data protection plan says if there is an incident, you have to publish it within 24 hours. It used to be 72 hours. You have to publish. There is a data breach that has happened in our organization. We are taking the following measures to mitigate the risk. What is the impact to the end users? What is it for the organization? Everything. So communications is one of the key steps in this response process. Then analyze, mitigate, and how do we improve my system? Then how do I recover it? No. It is a universal. See, this is a guideline. When they say NIST gives this framework, by adopting this framework, then you, for each of these things, you may have a method. It's not that you have to follow only one way of doing these things. For example, asset management. It's a NIST is a global organization. Okay. Exclusive for? No. It's a framework regarding cyber security. How do you secure systems? Okay. What are the steps that you should follow? There are so many documents available in the NIST. Okay. So it's a guideline. These are the stages through which you ensure that you do a risk assessment. You protect. How do you protect your systems? Is like I said, not every organization will have enough money to spend, right? But still, how do you do that? You have to document it. Okay. If somebody is, an NGO, they may not have enough money. They may be okay with certain risks, but you have to document these are the risks that we expected. These are the control measures that we are putting in place, and we are okay with that risk, right? Like I said, if a system is down for 2 hours, what is my loss? Am I okay with that loss? This for the organization to decide. But if there is a legal requirement, then you are bound to adhere to the legal guidelines. Okay. If you are a business entity, banking, you are managing millions of customers' data. You cannot say that I cannot restore my system in the next 1 hour. HDFC Bank recently got and everybody was publishing that system is slow, system is no, I am getting false messages from HDFC Bank, all those stuff, right? So the frameworks are just to ensure they give you some guidelines. If you follow these practices, then you can minimize your risk. They are not uh, mandatory, but it's a standard, right? If you say that, okay, how do you walk on the road? Hey, you walk on the pavement. It's a guideline. But if you walk on the road, you know you are supposed to know what are the risks, right? And this is a key concept, security by design. We talked of when you develop an application, how do you develop it, right? With the security in mindset. So security by design is one of, no, we talked of least privilege. So as you develop the system, hey, who is going to have access to my system? Am I allowing only those people who are required to access the system, right? Defense in depth. We talked of least privilege. So we talked of zero trust security, I said, right? So defense in depth is like, even if the first stage I get compromised, will my next stage detect that? Will the third stage detect that risk? For example, network access control is the first step. Firewall itself should detect. But if the firewall due to some misconfiguration it has allowed, then I am reaching my server. In the server, am I restricting it? Right? Who has the administrator privilege? If the third party tries to get that administrator privilege, they can transfer it. That's called lateral movement. If I get access to one server in my network, I can easily access all the other servers in the network. So defense in depth is then, okay, I am getting access to my server. There is an application. Do I have authorization in place to access that application? So this is called defense in depth. Every stage you improve. So even if one system fails, the other system should take care of it. Default secure settings. Okay, there is something called fail secure and fail insecure. For example, if you are using a Windows laptop, you see a blue screen depth, right? Depth of blue screen, right? It crashes and it puts some garbage on your screen, 00 hexadecimal, all the stuff, right? It is it's called fail secure, meaning that your system is protected. There is some incident has happened which has caused the system to fail, meaning that fail recover is that, okay, there is a known patch, okay, or there is a system fault itself, and the system will recover, and then it will come to a login prompt. Okay, so you have to understand between, is my system fail secure rather than fail insecure. If there is a vulnerability in the firewall, okay, and if the firewall has failed, okay, for example, it should remain fail state sometimes, because it should, if there is a failure and the third parties get access to the system, which by default should be denied, right? So you have to understand, when I design my system, should it be fail open or fail secure? So it should always be like, if the firewall fails, the secondary firewall should take over. So that is called fail open. If one firewall fails, the other should take over. But if there is a problem, if there is an incident, then the second firewall should not take over. It has to be fail secure. It has to be denied. Then you will analyze what is the incident, why it failed. Then you open the system manually. And audit trails. We talked of how often do we do auditing? Every time. If every transaction, every access should be logged and monitored. This is what defense in depth. For example, right? So you have, say both are same. So when we talked about in brief in the earlier, right? Cybersecurity is all about so many things. So you have a perimeter security or a physical security. You have a data center, Google data center, right? It's a big campus. So you have compound walls. You have all those stuff, electric fences, everything. So what is my perimeter security? Then inside that you have a network, right? Corporate network. You have data centers, all the servers, storage, everything is there, firewalls, everything is there. Endpoint security is more about end user devices, right? So how am I protecting my laptops? Is every system is patched with the latest Windows patch, or whatever the Linux, all those stuff. Within that you have an application. An application resides in your server, or it could be in your laptop also. So what are my application security controls? And finally below it you have the data, which is the crown jewel. All you do is just to safeguard this data. So to safeguard this data, every layer, right? So that's where it's called in depth. If there is a problem in there is a breach in this layer, the next layer should protect, or the next layer, next layer, next layer. So this is called the defense in depth principle. End of the day is to protect the end user's data. And you see this in this side, you have a policy management. So policies are more of a guidelines, corporate level things. Hey, this is what our standard says. Uh, for example, interns will have access to only these systems. If you are in the database team, within the database team, you have so many databases. Which users will have access to financial database? Which users will have access to? These are high level things which are approved by the top management or board of directors. This monitoring and response, it's again a real time activity, real time monitoring, real time response, right? All those. So this is one of the things you need to understand. Defense in depth is very, very important. And sorry about it again, because it cannot be made more visible. So defense in depth across layers, for example, operations, technology, people, right? For example, defense in depth, for example, people, you take, right? If there is a flood, my data center is flooded. So which people will have access remotely to access the data center, right? Or I have a business continuity, as part of business continuity plan, I have a disaster site. If there is a disaster in my primary site, how do I restore from my remote site? Banking systems are mandated to have business continuity plan, disaster recovery sites across. If across regions, you cannot, for example, India have operations. Probably a disaster recovery system should be in Singapore or somewhere else. Okay, so defense in depth across layers. Okay, you have wireless security. Everything, it covers everything, systems and network, data security, physical security, for everything, every aspect. How do you ensure that there is a redundancy in plan? How do you mitigate those risks? No, these things will coexist. See, we will come to that. I will tell why, what is the need for cloud, why we went in for cloud. We will cover that. On premises will exist. So like I said, it's all about how much you have in or how much you can eat. It's based on how much you have or how much you can absorb, right? So every organization, startup, you have startups, you have established organizations, you have large organizations who spend billions of dollars in R&D itself. But for some organizations, it's all about existence. They cannot pay their employee salaries also. So it's all about, that's where cloud came into picture. Okay, we will see that, we will go into that. Alongside, we will see some best practices. Okay, ma'am was also asking about what is the best practice when you say talk about secure coding or development, management, operations. What are some of these things, right? These are some of the critical things: error handling and logging. When you develop an application, how do you publish your errors? What should be visible internally for the application? What should be visible for the end user? For example, if there is a wrong user ID entered or a wrong password entered, what do you show to the user? Incorrect password. But within your system, how do you capture that and interpret it? A error code 001, more than 3 attempts, right? Incorrect password. So error handling and logging, both are important, right? So if there is a retry of more than 3 times, that should be logged. Then only you can identify whether it was a genuine user who forgot his password or some malicious user trying to enter into the system. We talked of data protection, encryption, right? Hashing, secure protocols, all those stuff. So how do we ensure that that crown jewel data is getting protected, defense in depth? So this is one of the best practice. Configuration and operations. We talked of open ports, unnecessary ports being open, right? Access controls, not everybody having the same things. So when you configure the system, how do you configure all these things? Okay, and how do you in the operations well? How do you do that? Authentication. We talked of multi-user, multi-factor authentication, all those stuff, right? Whether it is the genuine user, biometrics, all those stuff. Session management. We said, no, you don't terminate your current session. You're bound to encounter problems. So how will you manage your sessions using cookies, all those stuff, right? Input and output handling. We said, right, input validation. Okay, if somebody is entering a wrong character, or instead of legitimate number of characters, any other special characters in your scripts, in your SQL injection we talked about, and finally about access control. So these are some of the best practices you should always follow, okay, at all stages, whether you are in development, whether you are in operations, whether you are in the network security, cloud, everywhere. So we may not have enough time to go through every point. I have probably, I think in NPTEL also you can have access to these things. So go through. Again, this is more of elaborating on the previous points, right? So it talks about in depth about every other point. Okay. So error handling and logging. What are the best practices within the error handling and logging? For example, display generic error message. See, error messages should not reveal details about the internal state of the application. You should not throw some, like I was talking about the Windows throwing blue screen, right? Hexadecimal values and all that, because it reveals information about what is the current state of your system. You should not. So it should be generic SMJ. For example, uh, unable to provide access to the system. Why it was unable to provide? You may not want to reveal to the end user, right? Incorrect password, wrong password entered, but you may want to understand what your application has thrown out as an error internally, and then have generic within your application, if this is the error, what should be the problem. Okay. So unhandled exceptions, you have to handle all those exceptions. Okay. For example, buffer overflow, you have designed your application to accept, for example, if it is an 8 character, probably 16 bytes or something like that. If there is a memory leakage and it consumes all the things, right? Buffer overflow is one of those exceptions. How do you handle all those exceptions? All authentication, privilege changes, administrative accesses. For example, any administrative access on the application should be logged, meaning that if I am a normal user, right, I try to change the password of somebody else, can the system allow that? Only the administrator should be able to reset my password, right? Or if it is self user can change the password, only for themselves they can do that. They should. This is called privilege escalation, right? That's what the hackers or any other malware, malicious people will try to do. They will first try to get access into your system, then they will try to do some privilege escalation. Hey, can I become a root user of the system? Okay, if the root user password is not hard enough, then they will know what is by default. Even the routers or firewalls, they will come with admin. If the organization has not changed that password, it is very easy for the person to get access, and then they will do lateral movement. Like I said, they will, from one system they will connect to the other system. So error handling and logging, don't log inappropriate data. See, this is from the compliance perspective. So compliance like GDPR and all that stuff, what can be logged, right? You cannot log everything. Then it will get to the privacy side of things. So what can be logged? So you need to take care of the privacy side of things also, and the logs also should be secured. If the log is available to somebody, that can also cause harm to your organization. So again, within data protection, we talked of encryption. See, you use HTTPS everywhere, right? Secure protocol. Disable HTTP for all those things. Then store user passwords. Use a strong iterative salted hash. Salted hash is like you have a plain text password, you hash it. Salt is like adding some extra characters, right? So what will happen is only the system will know what is the salt that you are using. Okay, salt is like more like a extra characters that I'm adding, okay, to the password. So when the user types his password, his or her password, that will be hashed first. Then I will know what my salt used in the system. I will add the salt. Then I will compare with the stored hash and salted password along with the real-time entered password. If that matches, then that will give access. Then securely exchange encryption keys. Encryption keys, like I said, I want to digital certification, all those stuff. How do you securely share your exchange keys? If I share it openly, then I will know what is the exchange. If that gets access to, by the third parties, they can easily, change the data. So from the data protection perspective, like I said, weak TLS configuration, transport layer security, because the data gets, transmitted to the other side through the internet. So how is it getting secured? Then use valid certificates from reputable certificate authorities. There are certain industry standard certificate authorities. Okay, so you have to get your SSL certificate only from those authorities, not from everybody else. Then disable data caching using cache. Like I mentioned, right? I talked about caching. You go to the internet cafe. The last session was not closed. I can easily do. So how do you disable cache? How often do you disable the cache? See, for example, people will say 10 minutes is the time. Beyond that, the session will get 10 minutes. In that process, the cache also will get 10 minutes. If that is open, then that is vulnerable, right? So how do you handle all those stuff? Limit the use and storage of sensitive data. Don't get unnecessary data and then store and then try to protect it. This is one of the key requirement in GDPR also. This is limited data. You have to say why you are collecting the data from the user, how you will use the data of the end user. So these are compliance requirements. Okay, you may not want to capture all the data of the end user as well. So from configuration and operation perspective, these are some of the best practices that you need to follow. Perform code reviews. I talked about static application security testing, analyzing the code when it is idle, only the code. Dynamic application security testing, I said, when the application is deployed and then you try to give some wrong data, whether application is behaving correctly, all those stuff. So testing is again one of the design review. Hey, this is what the intended scope of the application and whether the application is designed according to the business requirements, functional requirements, security requirements. This is more like a design review, code review, security testing. Harden the infrastructure. Deploy the patches at regular intervals as it is deployed given by the vendors. For example, you have a firewall, Cisco is the vendor, and Cisco releases a patch. They identify some vulnerabilities with one customer, probably they will release the patch and you deploy the patch. How do you deploy the patch? Is it in production? You cannot directly go into the production and deploy. You may want to do it in a staging environment or something like that. Test it. If that works fine, you plan for a change management, deploy it. So these are some of things, educate the team on security, define an incident handling plan. Like I said, if there is a problem, if one system gets a malware, then how do you identify and mitigate the risk of that getting spread to the other systems? This is from the operations perspective. The authentication itself has some list of best practices. Okay. Hardcore credentials. Develop a strong password and reset. Hey, password will expire in say 30 days, 60 days. Okay. How do you reset your password? Account lockout. More than 3 retries of wrong password. So these are from authentication perspective itself. These are some of the best practices. Store database credentials and APIs keys securely. Okay, you have a key to encrypt the end user's data. Where do you store the key? You should not store the key in the application itself, because if the application code gets hacked, then they have the key. Then they will. So what are the best practices? How do you store the keys itself is a very important thing. Applications and middleware should run with minimal. See, in the cloud environment, okay. So far we have talked about applications that we develop. In the cloud world, what happens is communication between machines. One server wants to connect to the other server, right? It goes with the user's mindset. For example, if I am the user, I am accessing a system, I give my user ID and password, right? Same way, if there is an application A, there is another application B. This application A wants to access application B to pull out some data. So how can this access? It's similar to the user ID password kind of stuff. Okay. So in that, you store that user ID and password, least control, need to know all those stuff kind of in a configuration file. So application A dynamically will pull that information, share that with the application B. Application B will validate, hey, this is the application A is trying to access my system, and then we can perform. Okay. So, and everything should operate with the minimal privileges. If it has, application A has to pull out only relevant data, it has to. It should not be allowed to pull out everything. We talked of session management as well, right? How you terminate your session, how do you close your session properly, okay? regenerate session tokens, timeout. So as part of session management, there is a user connecting to my system, how that user should behave, how long can they be idle, when should I terminate the session, in the next login process, okay, to ease the user login, do I still keep everything in cache? If I keep everything in cache for unlimited time, it is a problem. So session management, what are the best practices? These are all the best practices. Cookie expiration came, right? Place a logout button on every page. Most of the users, you simply close the browser button, right? But it's not going to terminate your session. So within your application, you will see, okay, if this user logged in at this time, it's more than 10 minutes, there is no activity after this, I'm going to terminate my session from the application perspective. So next time when you log in, it will ask for a user ID password. These are some of the references that you can go and see. I talked of OWASP. From the input and output handling, what does the user enter, how am I validating it, what is the kind of output that it should do. So contextual output encoding, for example, depending on where the output will end up in the HTML, the output must be, there is something called encoding, HTML pages, right? How do you see that? You see a beautiful web page, right? You have various characters, ASCII characters, everything. So there is an encoding that happens before it gets rendered onto your HTML page. So how do you take care of all those things? Whitelist and blacklisting, like said, what is allowed and what is not allowed. So you have to be very careful of it. And parameterized SQL queries, you will understand as you develop your applications. You just pass parameters. For example, I want my marks. What is the minimum thing that I need to provide? My student ID, my subject ID, then I will get the marks. Okay, subject ID 1, 2, then it will give me 2 marks. Right? This is called parameters. You just pass the parameter and then it will load. Rather than hard coding. For example, if you have 100 students, you don't write 100 queries where student age equal to 1, 2, 3. You just share it. Then based on what is the input value, it is going to render the output. So again, probably when you have time, you can just go through. These are all the best practices. Okay. So again, these are guidelines from NIST and other people as they publish it. By following this, you will have access controls. Again, we talked in depth about all those access control, right? Discretionary access control, mandatory access control, role based, rule based, attribute based, right? For example, say don't use unvalidated forwards or redirects. This is what the malicious people will try to do. There will be a link in your application which is supposed to take you to a different page, but the intent of the malicious person is to inject a script in your application code that will point to a different site. For example, you can try it out. For example, ICICI Bank, instead of I, they will put an L which will look similar to an I. So instead of an ICICI Bank, it will land up a different site which will look like an ICICI Bank. They capture your data and then probably they will use it anywhere else. So apply the principle of least privilege, because these things will help you to minimize the risk. Again, I said this is not going to eliminate the risk entirely, right? Least privilege is like, hey, I'm minimizing my damage by giving access only to this portion of it. One record losing is fine. I'm losing your entire corporate data set. It's a colossal damage, right? So these are the best practices. So again, what are the common vulnerability exposure risks? And I have given what are the safeguard measures. For example, broken access control. What is it, right? For example, it can help hackers change user privilege settings. If the access control, like user ID, password, authentication, all those stuff, if there is a break in any of these things, that will help the access change the user privileges itself. An administrator may lose his privilege. He may not be able to log into the system because somebody else has changed their privilege. So, and what are the safeguard measures? For example, continuous penetration testing. Okay, delete accounts that are, for example, an employee quits an organization. Can he still retain the user ID, password, access to different systems? No, because They may try to access the system even after they leaving the organization, right? So these are the best practices. Okay, conduct regular penetration testing, proper session management method. Same way cryptographic failures. How this, for example, credit card or identity theft is mostly because of cryptography. I am not encrypting my data. I am using a weak encryption algorithm. I am using a lesser size of key. This will result in problems. So how do you do that? Most of the time, turn off autocomplete on forms. For example, you type in your mobile. The first time you type, the next word automatically comes in, right? That is through a technology called federated learning. So in the forms also, mostly, most of the websites you visit, you type your first name. Probably when you move to the last name field, it will automatically get added, right? Because of the caching and cookies and other settings. So turn off autocomplete on forms. Use data encryption, whether it is in transit, at rest, or in motion. We talked of it. So deactivate caching. This is one of the best practice, right? We said caching, disable, cookie deletion, session management. These are small things, but most organizations somewhere they fail. That's what when you look into the breaches, most of the organizations, right? Be it Sony, Verizon, these organizations get breached. How can they be? It's the same. They know the best practice. It's not that they don't know the best practice, but somewhere in the process, change management or something, they will miss out. We talked of SQL injection and all those stuff, right? So it could be through SQL operating system, no SQL or LDAP. LDAP is more like an access control thing. So what we talked of SAC, static application security testing, right? And in dynamic application security. Parameterized queries, we said. Don't hard code the query, use parameters so that you don't know what to pass, right? So you will minimize the risk. Use a safe API instead of an eliminator. Server side validation and intrusion detection system. So these are best practices and guidelines. Okay. Insecure design. Okay. You have to follow a safe development life cycle. Integrate checks at every layer. We talked of defense in depth, right? So even within the application, right? If the first level of your application user ID password, if somebody knows about the user ID password, they log into your application. But after that, can you take additional measures? Once in a while, you throw a pop-up just to confirm whether it is a genuine user. You may throw a pop-up. We talked of security misconfigurations, right? So how do you ensure what should be, so you have a segmented application architecture. No, don't allow the entire application to be accessible by everybody. Okay, within the application, be it a payroll, be it finance or anything else, right? You provide only limited exposure. Hey, this is the time window that you can access the application, right? This is the location from which you can access the application. So these are the measures, which will ensure. And again, continuous monitoring, we said, right? Continue. For example, in the cloud, one of the why people go to the cloud is again is anytime I can launch a server, anytime big billion day sale, for example, right? Flipkart sale, Amazon sale. They may not want to buy, servers worth millions of dollars just for that one day of sale, right? So what they will do, they will go to the cloud. As the users increase, it will launch additional servers, and as the demand comes down, the service will get shut down. But in that process, you have to do continuous monitoring. Hey, yesterday because you have in the cloud, you have cost management, budgeting, and all those stuff, so you can easily track. You have a plan in mind. You say this is my budget. All those stuff. You can track. But if you don't track, somebody launches a new service. Okay, some administrator deploys a new thing, and it constantly increases the number of servers. Your cost is going to go up. So continuous monitoring and security gap misconfigurations is very, very important, and it's one of the best practice. So again, most of the top 10 is again identification authentication failures. Okay, compromised passwords. Like I said, your Google password, you have not reset it in the recent time. You have not, even though there was a communication from Gmail, you forgot to change your password. It's a compromised password. So people are going to use that compromised password, anything, keys and all that stuff. So again, multi-factor authentication, Users with administration privileges should not use, like I said, admin. If I am the systems administrator or network administrator, I should change my password. Whatever the vendor provides, immediately I should change it. And session management. So again, data integrity, we talked of encryption, proper exchange, cryptographic keys, and same way, check whether your continuous integration, continuous delivery pipeline, all those stuff, every stage, every process, whether it is complete in shape, so that at least it gives you a chance to find out whether there is a gap. Logging and monitoring, we saw it multiple times. The server side request for example, this is mostly because of an application fetching a remote resource without validating. That's what I'm telling. In my application, I have a link which ideally should take me to an ICICI bank. But in that process, it is leading to different site. This is called server request forgery. So instead of a genuine URL, without validating, it goes to a different URL. Okay. So you have to log accepted and blocked network flaw, ensure URL consistency. Hey, whether this is the same URL I am supposed to have the user taken into. If it leads to a different website, how do I find it out? Okay. So now we will just have a shift to the cloud. Okay, why cloud came into picture? Every organization used to buy a server, have an administrator, network administrator, firewall, all those stuff. As AWS, Amazon was using their own infrastructure for their own purposes. But finally they felt this could be made as a service so that every organization can use it. Like I said, just for the one day, why I need to buy thousands of servers and then throw it out? Or even if I have some set of servers, the usage of the servers, right, is not constant throughout the day. Only when all the users log in, there will be peak usage of CPU, memory, and everything. Rest of the day it is idle, right? So cloud came up with certain things which provide as an advantage to every organization, right, from the cost perspective, availability perspective, and performance perspective, right? So we have set of on-premise servers. There is a need for just for 2 hours of a day when you get more users. Only for those 2 hours you connect to the cloud. During that time you launch some servers, and as time goes by you shut down the servers. So you have availability, you provide users with the best performance, you are able to manage the cost. Okay. So in the cloud, again, there are 3 major categories. One is called the infrastructure as a service. So infrastructure as a service is I am availing only the compute, or I just want only storage. I have my users, they are uploading photos, my storage is limited in the data center. So I am just availing storage as a service. I will just have the data sent to the cloud, store all the photos there. Okay, it's a storage as a service. Same way servers, I just want additional servers only for that period I avail it. This is infrastructure as a service. So platform as a service. Okay, now I want my developers to develop an application in the cloud, and I want all the tools, technologies, everything to be there, and the hardware also. Okay, then you go for a platform as a service. And the final one is called the software as a service. For example, you have CRM applications, Salesforce, right? I don't want to develop that application. I don't want to use the technologies, frameworks, hardware, everything. I want simply Office 365, right? Why will develop my application, email, all those stuff, right? I will consume it. So you go with the SaaS model. And how these models work? For example, somebody asked, right? How do I think she asked, right? So in the on-premise environment, what is the responsibility of the corporate? See, the only thing is between the cloud and the on-premise, there is a ownership level. Where does the ownership end? Where does the ownership start and where does the ownership? So in the on-premise world, the organization is responsible for everything: physical security, network security, virtualization, operating system security, database security, application security, everything, right? This is like a co-location. It is called co-location. You don't have a data center, but then say Tata Communications or Airtel, all those providers are giving environment to host your servers. So you have your servers hosted in the other place, which is called co-location. So in that, the green is the vendor has the control. The facilities control you don't have, but rest of the things you manage the servers. They give you only the environment. The third is managed services provider. So managed services provider is they provide everything. They take care of the security, all those stuff. When it comes to cloud, we talked about infrastructure as a service, platform as a service, SaaS, software as a service, right? So if you see that in the infrastructure as a service, the green one, the AWS or Google, they are responsible only for the servers, network and facilities. Rest of the things you are responsible. Okay, still you deploy the server, you deploy your storage, you configure it, everything. Platform as a service, see it goes up till the operating system. AWS is responsible, for example, right? Because you are leveraging only the database and applications. You leverage the tools and technologies to develop, and anyway application security is with the corporate. And finally, in the software as a service, everything is owned by the provider, cloud services provider, right? Right from facilities all the way to the database. You don't use Oracle, you don't define anything. You are consuming it as a service, and you are responsible for the management of data. Data is not responsible. Data management not their responsibility. What encryption keys you use, how do you back up the system? It is your responsibility. So this is the major difference between the on-premises side of things and the cloud side of things. So we saw this anyway. Okay, typically if you talk of say application development, software development, all those stuff, right? There are some stages. You start with the design stage. Hey, this is how my system should be designed. How many users will access my system? From which regions of the world they will access the system? What duration of the day the system will be accessed? All those stuff. What are the business requirements? Everything. Once the business requirements, translate into technical requirements. Okay, how the system should be defined, what technologies we will use, what frameworks we will use, okay, whether you will use Java or which database, all the stuff. Then it goes into the development life cycle. And sometimes you may want to, like I said, the third party integration. Hey, I want to integrate with the cloud also to store my photos. Okay, AWS S3 bucket, I want to store my photos. Or I want to use Facebook library to enable Facebook login for my users. So how do I integrate, with the third parties? How do I use their APIs? And what kind of a cloud services? Okay, so these are not mandatory, but design, development, testing, rollout. That is the typical cycle. But because of cloud and third parties, this is how the current software development architecture look like. Again, we briefly talked about why. Okay, cost management, performance management, availability management. That's where these were the top drivers of going with the cloud. Right? Cost, easy to implement. I don't need to worry about setting up buying the server, getting budget approvals, waiting for the server to reach my location, then deploy it into the network, test. I just want a server. I go, I have a user ID password. I say this is the server I want to a micro or a mini or a large. What is the instance size? I select the instance size, click, at the click of a button it comes up. So ease of deployment, and it's reliable. When I say reliable, compared to our on-premises, cloud is highly reliable because they have redundancies in place. They have redundant locations that can provide the compute, and scalable. And you see this pay-per-use billing. I use it for 1 hour, I use it for 10 minutes, I only pay for the 10 minutes. I'm not paying hefty, like, I buy the server, say $10,000. I don't buy that, right? So these are the major advantages of, cloud compared to your on-premise things. We talked of shared responsibilities, right? So when you say that you go with any cloud provider, what is it that the cloud provider give you? Uptime, 99.99. If you talk of S3, Amazon S3, storage, that has 11 nines of availability, 99.9999% it is available, meaning that my data is available. And there is one thing called durability. So there is a difference between availability and the durability. Availability is how far my systems are up and running, whether they are available. Durability is how long the data stays in that system. Okay, whether that is durable till the lifetime, till I delete my data, will that be available? For example, if I have my systems configured and data I am storing my photos in one location, right? The cloud provider gives you an advantage, saying that even if data is lost in that particular location, there is a storage problem, still that data is replicated by default to another region, to another region. So these are the major advantages. Can I afford to buy 3 storage systems just to ensure I have redundancies in place? No need. So these are major advantages of the cloud: uptime, availability, network, and compute. What is the responsibility of the cloud customer? Data integrity is not the ownership of cloud provider. So I need to ensure I use proper encryption algorithms, keys, cryptographic keys, application security, all those. Identity management. It is my users who are accessing the cloud resources. So I am responsible to configure my identity and access control mechanisms. And data encryption and client side network security. So where are my users accessing the systems from? Are they from their home they are accessing, or from my corporate environment? So this is called the shared responsibility. So the cloud works mostly on the shared responsibility model. And again, what are the phases in the security thing? This is one, again, the best practices. You develop, you build, you package the software, you test it, you deploy it into production, then it becomes operational. So at each stage, what should be the focus? For example, in the development stage, you look for static code analysis tools. Like I said, you develop your application, the static code tool will analyze if there is any vulnerability in the code. That will automatically do the scanning. Again, when you want to build, there are tools like Jenkins, okay, that can be used to create your multiple builds, all those stuff. Again, you have to package. You have multiple teams develop that. You put it as a package. That becomes your core application. In the testing phase, again, like I said, I told you about this static and dynamic application security. You deploy the application in the staging or testing environment. You try to inject false data, whether the application detects that. You inject genuine data, whether it works fine. So this is the dynamic application security. Once everything is through, security and everything, then you deploy the packages. Then it becomes operational. Once it becomes operational, we talked of continuous logging, monitoring, error logging, and all those stuff. So again, I have just given a comparison of what are the key security, cloud security features across cloud providers, be it AWS or Azure or GCP. Okay, what is the service? What is the set of services that they offer? What are the best practices across these things? Okay, if you talk about network security, okay, AWS has something called virtual private cloud, VPC. They have a firewall manager, security groups. These are the concepts of AWS. They will all be similar. Maybe the keywords and terminologies will be different because concept is same, right? For example, again, here they call virtual private network. In Google Cloud, it is called again VPC. Here also it is VPC, virtual private cloud, right? Here it is AWS firewall manager. Here it is a Google Cloud firewall, right? Again, for example, private connectivity. I want to connect my data center with the cloud. What are my options? Okay, you go through AWS. It is called AWS Direct Connect. So from my corporate network, I will have a high-speed connectivity to the AWS data center. Here it is called Cloud Interconnect. Only the name. Okay, rest of things are same. I am connecting 2 points. One my on-premise to the cloud. Okay, so for example, DDoS protection. We talked of distributed denial of service. Somebody using vulnerable systems to send multiple concurrent requests to the data center to disrupt the system. So what are the protections? In AWS it is called AWS Shield. In Google Cloud it is called Cloud Armor and Azure DDoS protection. So these mechanisms will ensure that they detect at the first stage itself, hey, so many requests are coming, I have to stop it. Because the systems used to get only this many requests, at this duration, for, no, at this time of the day for this one. If there are only 100 requests always seen between 10 and 11 a.m., but now I am saying 100,000 requests, it will immediately stop. So from the security architecture point of view, what are the frameworks? We talked of NIST framework. So AWS has something called a AWS well architected framework. How do you design your systems, applications within the AWS environment? What are the best practices you should follow? How should you deploy your firewall? How should you deploy your storage? All those stuff. So Google also has the same thing. And these are the account manager. How do you manage your users? How do you create your users? How do you manage your budget? How do you manage your cost control? All those stuff. Right? And hybrid cloud is more like, okay, I will have my applications running in the on-premise. I will have the same set of applications running in the Google Cloud, AWS Cloud. How do you do that? Okay. Or if the cloud fails, how can I? So that's where these things come in. AWS has something called Outpost. Okay. There is an open source something called OpenStack, and Azure has something called Azure Arc. So again, from the multiple cloud providers, what are some of these things available? From the security, so logging and monitoring, again, what are the things available within AWS Cloud? In all the other clouds, GCP and open source, what are the things available? Then network flow, there is a huge network, right? There is always a traffic goes through the network. How do you analyze the network? How do you analyze the network activity? Okay, what is happening? So how do you store those logs? So in AWS it is called VPC flow. Here also it is virtual private cloud flow logs, right? Firewall logging. And threat monitoring. What are the tools available within AWS and other clouds, right? And vulnerability scanning. How do I scan my applications for vulnerability? If your application is in AWS, you can use the Amazon Inspector. It will analyze your application code and say what are the vulnerabilities available. In Google Cloud, it is called Web Security Scanner. So same thing for anything else, single sign-on. Okay, like I said, I log in once, I'll have access to all the applications. Federated identity we talked about, right? And least privilege. How do you control? How do you get into the least privilege within the cloud? In AWS, you are called something called Identity and Access Management Access Analyzer. Hey, it will constantly analyze. This user probably yesterday had only this privilege. Today it has got changed. You can go through the logs and then detect it. It is called Cloud IAM in the Google Cloud and Azure role-based access control we talked about, right? This is the new terminology. See, it used to be development, it used to be operations, there used to be a separate security department. Now it's all got merged. It's called DevSecOps. So instead of DevOps, now it has become DevSecOps. So how do you do that continuous integration, continuous delivery? What are the tools and technologies available, say in AWS, Azure, GCP, and third party and open source? Okay. And this one, infrastructure as code. Okay, you just remember this keyword called IAC. Infrastructure as code is like you don't configure your servers manually. Previously, the administrators used to buy a server, log into the server, create users, or for example, you want 10 servers to be launched in AWS or 100 servers. How do you know that? You cannot go and provision server by server by server, right? So infrastructure as a code is a way where you, like an application, there is a template, there is all those things. Use those templates. You define, it's like an XML file, okay, YAML file. You will define number of servers, 10. That's it. It will automatically provision that many servers in AWS Cloud. If you said it. In Google Cloud, you want something, you use that code, change the values, deploy it. So infrastructure as a code. So in AWS, it is called Cloud Formation, and here it is a Cloud Resource Manager. And Terraform, that is the tool commonly used by everybody. Terraform is used by every organization to provision the cloud resources using templates and code. And operations management, again, this content delivery and protection. For example, you have a website which is accessed by millions of users across the globe. So meaning that response time has to be pretty fast, right? How do you ensure that? So meaning that whatever the static content, you have images in your website, you have some dynamic content. Dynamic content is more like a fetching the data from the database. Rest of things are static, right? So this content, if it is cached closer to the user, for example, there is a user from India, but the server is in US. think of the latency to download the content. It's not going to happen soon. So there is something called the content delivery network. There are organizations like Akamai and Google, everybody has it. So they will replicate the data to all the places wherever the user is. So the data remains very close to the user, but as the user types in, data gets downloaded. So content delivery and protection. So AWS has something called CloudFront. Okay, it will help you to speed up delivery of the content as well as protecting from the DDoS attacks and other stuff that we talked about. So I talked of Akamai. Akamai is one of the first organization that helps organization to cache the content closer to the user. Cloudflare is another organization, and Imperva is an organization that helps protect this content. For example, from any other attacks. We talked of cross-site scripting, server-side request forgery, and all the stuff, right? So, and microservices, probably you would have heard of this keyword. So previously, what happened in every organization used to develop a full-fledged application that will have HR functionality, payroll functionality, financial, everything, right? It's when you make a change, if there is a problem, the entire applications get problem, right? So microservices helped you. Hey, split it up as a service. Okay. For example, you go to Amazon.com, you are visiting the site, you are browsing what are the products and features, you are just browsing it. But there is another service called, okay, you have found out what the item you wanted. Now you are going to put it into the shopping cart. There is the next stage where you want to make a payment. Now, if everything is in one, if there is a problem with one part of it, the whole application becomes unavailable. If it is a service, the user who is browsing will have no impact on the user who wants to make a payment. If there is a problem in the payment side, it's not going to impact the other user. So microservices architecture is one way, and AWS has this called API gateway, and same way GCP has API gateway. And again, microservices, for example, we talked of endless number of users accessing it. Same way microservices, you need to control, right? If I am getting 100,000 requests through for a particular service payment, then you need to monitor. You have to have a threshold. You need to control. You need to take corrective actions. Why this many requests come? So, and cloud providers have given you all those tools. Again, from the governance, risk, compliance perspective, what are the tools available from all these cloud providers? Because we talked of continuous monitoring and logging, right? Even if you are in the cloud, cloud gives you the tools and technologies. You have to leverage these tools and technologies and then monitor and everything. It's not that the cloud service provider will do all these things for you. That's where the IaaS, SaaS, and PaaS, the frameworks came in. If I'm using the service as a software as a service, I don't need to worry about anything. But managing the end users' data, privacy, that is my responsibility. So the cloud services provider never takes ownership of your data, your customers' data. See again, there are two things, right? Security and privacy. There is again a subtle difference between privacy and security. Okay, privacy talks of who is the user, what is sensitive about that user, what data is sensitive about that user, age. I may not want to reveal the age of a particular user, right? Then I can easily target, what items I want to propose. GDPR has a stringent requirement from this privacy perspective. But security is more about, I am storing a data, be it sensitive or insensitive, whatever it is. How do I secure my systems? How do I secure the data? So security is more like it covers the privacy. There's another set of things called trust and ethics, right? Ethics is more like how I am operating as a business. Okay, what are the policies and procedures I have in place to safeguard my end users' data? Am I operating ethically? Trust is more from the end user's perspective. Can I allow this organization to make use of my data? So that's where, if you see most of the data protection bill, other stuff, any website that wants to collect end users' data, they have to list down for what purposes they are collecting the data, how they will use the data, will they share the data with any other third parties. So all those things are So there has to be a trust. So trust, ethics, privacy, security. These are the key words that you should remember. And what are the, like, I may not want to go in depth into this. Again, these are some of the best practices, secure coding practices. So during software design, what are the best practices you should follow? Okay. During software development, what is it? During implementation, what are the best practices? Okay. Just go through these things when you have time. Probably, it may be too early for you to fully understand all these things, but this is how it works. Okay. For example, in the design stage, you have when you before even you develop, right? That's the design stage. First, you need to have the what is the security and privacy implications. Hey, are my users in Europe? If that be the case, then what should be my privacy requirements? What kind of data can I collect? Okay, with whom and all we will share the data, right? And what should be my security mechanism? So these are the best practices. So same way it goes for any other thing. Okay, during software development, only authorized developers should have access to the source code. Can everybody have access to the source code? Hey, that is my IP. That's my intellectual property. I am developing an application. I cannot allow everybody to take the code with them. So during implementation stage, how do I do that? What are the settings that I should do? Configurations, right? So again, what are the best practices when integrating with third-party software? I want to integrate Facebook into my application. I want to incorporate Instagram. Okay, I instant messenger of anybody, any other application. So at that stage, what should be my best practices to be followed? Privacy principles when using APIs. When I am trying to use API of any other third-party like vendor, what should be my best practices? Cloud. When I want to leverage cloud, we talked of, right? Who is responsible for what? Have I clearly understood what will be my cloud service provider will do? For example, security and privacy should be carefully, the developer should consider how the cloud provider could be used for example, in the cloud, you have a set of administrators who are managing the cloud resources, server, storage, and everything. They are common people. Okay. So as if you are preparing for your CSP, you will come to know. So these administrators probably don't know who is the customer. They are managing the infrastructure. If they come to know of, okay, this is the customer, okay, they may even grab the data. They are doing backups, all the stuff. They may easily share the data with any other customer, right? So but the responsibility is on the onus is on the customer. You should carefully design all these things. So again, some of the additional things, for example, threat modeling. Okay, when you design, okay, you have to identify what are the potential threats. We talked of any system, any deployment, any server. We talked of natural calamities. Hey, here is my office. Here is the data center. For example, if it is say near the seashore, okay, what is the damage that could be caused by the air? Okay, about earthquakes. Okay, if you are in California, it is more prone to earthquake. If some areas in more prone to flooding. Okay, so what are the threats and vulnerabilities? Secure coding practices, like we talked of input validation, output validation, and error handling. Don't show all the errors, right? Only make generic errors. So these are the best coding practices and mitigate the common vulnerabilities. Least privileges. Again, this may seem to be repetitive, redundant, all the stuff, but the emphasis more on these are the things that one is supposed to take care of. Then that will ensure your damage is very, very minimal. See, secure development, software development life cycle, don't confuse it with secure development. It is SDLC commonly is known for software development life cycle. But when you do the SDLC, it is also meant for secure development life cycle. When you do it, have security checkpoints everywhere. For example, requirements gathering. You ask the end user, hey, what should be your requirement, key requirement when it comes to security? Okay. Because if you make it hard, for example, in the name of hardened security, you say your password will be 25 characters. How many users will be okay with that? I want only 8 characters. I don't want, these are some of the requirements, but alongside security considerations. Okay. Encryption and cryptography, we said data at rest, in motion, or storage, wherever it is, in use, at rest, and in transit. Stored passwords. See, for example, what is the best practice? Stored passwords using bcrypt or PBKDF2 algorithms to safeguard. So, what is the right algorithm that you want to encrypt your passwords? Okay. Configuration management. Okay. For example, web servers to disable. See, this is probably you can try it out. You visit any website, it gives you an URL. Okay. Right from the right side, you terminate it, you go to a particular directory. For example, any university, for example, it could be used in any university. You find a PDF document, okay? It gives you that. You remove some portion from the right, then it becomes a particular directory, right? You may be able to view the contents of that directory. You go one directory before that, you may be able to. You may not want all of that, okay? That is called directory listing. So, and implement SSS TLS protocols, because TLS is like transport layer security. It works between the end user and the server. So it has to be properly secured. SSL is the old way, TLS is the new one. And properly assess the vendors. Hey, from whom I am buying the servers, Cisco, or Juniper, whoever it is, router, server. Because, for example, India has a stringent requirement from whom and all you can buy a hardware, because most of the chips are designed in Taiwan. The hardware, whatever is there, be it a laptop or a server or store, the internal chips, most of them are manufactured in China or Taiwan kind of stuff. So there is a high possibility that data may get transmitted from your, without even you knowing about it, it may get transmitted. So proper assessment of third party, are they reputed, are they certified, right? Whether it is permitted. So that is, through this ISO 27001 certification mandates that. Secure integration protocol, we talked of secure APIs, web services, whether everything is secure, every stage, every touch point, whether everything is secure. For example, using OAuth or OpenID Connect, for example, these are the standards. Okay, when you use Google identification method, okay, or any other federated identity method, they use these methods, OAuth and OpenID. Again, regularly monitor and assess third party service. For example, today you have done the validation, you are connected with some supplier, okay, who is, you want to integrate, you want to ease the process of payment, right? So as the vendor supplies, you will pay. For example, you take Walmart. So Walmart is a global organization, everybody heard of, right? So Walmart never places an order for any item with any vendor. So Walmarts provide access to their shelves. Okay, you go to the shop, you have all the items in there, right? So the vendor has access to what is available in real time. And once it reaches you call it the inventory threshold, right? For example, I have 100 items today. I sold 90 items. I will not place an order with the vendor because there is a lead time. I have to place an order. Vendor may have the supply or not. They may say it will take 3 weeks. No. So Walmart gives the visibility. The vendor will have real-time access. Immediately they have to plan to ship the items. So if such is the end user experience that Walmart wants to provide to their customers, you are integrating with the suppliers. So now, if there is a vulnerability in the other side, then Walmart also is in trouble, right? So this is where the API integration, third-party software, constantly you have to check their systems also, whether there is a vulnerability in their system, whether they have done the patching. All those steps are very, very important. We talked enough about authentication and authorization, rate limiting and throttling. I'd say you use a cloud gateway, API gateway, right? How many API requests can be simultaneously allowed? Okay, what is the threshold for that? How I block that? How do I monitor? This is very, very important. So you have to set limits on the number of requests per minute or per hour based on the user access. Okay, so you may not want, because the system will crash. So the cloud, what will happen is it will launch additional API servers, but you are going to incur the cost, or it could cause damage to your other system because you are allowing unnecessary API requests. No, Input validation, again we talked about. You have to validate if you control it at the entry point itself, what data gets entered, you are minimizing the risks, right? Somebody, after allowing, anyway they have entered into the system, they will cause damage to any other part of the system. Again, we talked of data encryption, identity management. See, data residency and compliance. For example, where do you store the data? We talked of GDPR compliance, right? So, GDPR, any European citizens' data, there is a compliance requirement where it has to be stored. It has to be within Europe. It cannot reside anywhere else. But for example, say for example, organizations like TCS or Infosys, there could be some service providers who will make use of this data to generate reports for the organization. So there is a strong compliance requirement right from where the data centers are located within the geographic boundary, mainly for compliance like GDPR or a healthcare HIPAA kind of compliance. Again, some best practices. Say for example, there is a concept of code signing. Okay, so you might have heard of JIT, right? You develop your code, you deploy it, you store it in that JIT, you do JIT commits right through. What is a signed commit? A signed commit is a way of signing, or it's more of an approval. Okay, you stamp an approval on the commit made. Hey, yes, this is certified. I have tested it. There is no vulnerability. It's called code signing. So it uses a digital signature algorithm. It's called a GPG kind of thing. So code signing is one of the best way to, and why? Because it ensures authenticity, integrity, and non-repudiation. Non-repudiation is a concept again in the security world. You cannot deny that I have made the changes. It ensures that whoever does it, you have done it. It's called the non-repudiation. You cannot say I didn't deploy this code. So it's helpful in the multi-developer environment because so many people develop portion of the code and then do the commit, and then it goes through the continuous integration and deployment life cycle. So what are some of the concerns? See, we want to use cloud for mainly for cost reduction, performance, availability, and across locations. Okay, so there are benefits, but again, what are some of the concerns that clients have? For example, corporate. So lack of forensic data, because the cloud provider doesn't allow you to step into the data center. You cannot visit the data center. You don't know where the data center is. So you don't have any visibility of what they do, who are the administrators, where do they back it up. So this is one of the problem. Like I said, data loss and leakage. What if the administrator comes to know of, okay, you are a banking client. Can I sell this to your competitor? So data loss and leakage is one of the concern. Privacy is a concern. Confidentiality is a concern. If there is an incident, they give you some guidelines. My storage is 11 nines available. My servers are 5 nines of availability. All the stuff. But still, if there is an incident, they may say there is a problem. That's all. So still, that is your owner. And accidental exposure, again, it is like and legal and regulatory compliance. You have to ensure that if you are a healthcare organization, what are the certification standards that they are following? Most of the cloud providers will say that yes, we are already certified to PCI, payment card industry standards, healthcare SOX standards, HIPAA standards, GDPR standards. But to ensure that, still it is your own responsibility. And data sovereignty and control, where do they store the data? Still it is a concern. You don't know where they are storing the data. So again, just to elaborate on the same point, so we have the infrastructure, you have people and data. But again, within the cloud, see, the same principles apply, right from authentication, access controls, approvals, user behavior analytics. See, you want to monitor your users, who is doing what. Is somebody creating new instances, or the administrator is creating some additional administrators without even you know about it. So when you are using cloud, all these things you should do: logging and monitoring, right? Report, data discovery, encryption, key management. Okay, where do you store the keys? Because You are using cloud services. Cloud, there are multiple ways of storing keys, okay, encryption keys. You can generate the key in the cloud, store it in the cloud, or you can have, there is something called a client side key management. As a user, I will, when I send the data to the cloud to store, I can pass the key also, because that is the best practice rather than storing the key in the cloud. So what are the things that you want to do? And hardening, how do I secure my server, storage, everything, that is. And logical segmentation is how do I segregate my networks, okay, this is the network for this region, this set of applications, all those things are, these are some of the considerations that you should have. So this is some reference architecture, okay, who is responsible and all the stuff. For example, how hard it is. For example, say identity and access management, it is harder in the infrastructure as a service environment. Why? Because the customer is responsible to take control of the identity and access management. In the software as a service environment, it is very easy because you just say this is the 100 users that I want to give access to my application. That's all. So it becomes easy there. So if you take network security, application security, again, see if you say application security, the platform as a service and infrastructure service, it is little harder. Why? Because you have to set up your users, you have to manage their identity and authentication. See, but physical security, like I said in the cloud, you don't worry about it because it's the cloud service provider who is taking care of the environment. Same way, backup and requirements more or less, all these other stuffs are common. In every, be it IaaS, PaaS or SaaS, security, log event monitoring, backup and recovery are common things. It's the same in any service model. See, again, sorry about it, this may not be visible. Probably I will try to get this shared again. This is against a reference model. Okay, what is the reference model that you want to follow in the on-premises, infrastructure as a service, platform as a service, software as a service, and for endpoints like your desktops and laptops. So in the cloud, what are some of the best practices that you can adopt? When it comes to data encryption, okay, cloud gives you tools and technologies to have the data at rest and in transit by using proper encryption mechanisms. The best practices is to, like I said, use your client side key management. Alongside the data, you send it to the server so that it gets encrypted. Okay, don't store the keys in the cloud. And secure protocols, we talked of TLS and all those stuff. Okay. So again, when it comes to access control, use strong passwords, multi-factor authentication, and role-based access control to limit the privileges. Again, from the monitoring perspective, monitor the user activities. What does the user do? Okay, log everything and then monitor that. System logs, server to server communication, network communication, store all those logs and network and system logs. From the network security perspective, again, firewalls, intrusion detection systems, intrusion prevention systems. There is again a small difference between IDS and IPS. Intrusion detection systems, I mentioned about it, right? How many users are coming in at the same time, what it was yesterday, last month, it will detect. Okay, it works based on the pattern identification practices. So it will only detect and then you can configure some alert. But whereas intrusion prevention systems, it will act. It will work like an IDS, but it will go one step further and then block. Okay, if for example, if this is coming from Zambia or from Nigeria, right? So you can have a setting saying that if this is the global IP, because every country has a IP range. So if this IP is identified, immediately it will block. So you are protected. Same way, it will work based on principles of IDS. It will find out the pattern. This is the pattern that a transaction will happen. If there is a deviation from that, it will block. So intrusion prevention systems are one step above these IDS. And VPN, anyway, you're right. We talked of it, right? But to private network. How do you access it? outside of your corporate environment. So in the cloud again, depending on what service model you use, infrastructure as service or platform as service, then who does the patch management, right? In the except the IaaS, because in the infrastructure as service you are buying the server, so you need to manage the operating system, apply the patches. Whereas in the platform as a service and software as a service, it is the ownership of the cloud service provider. So these three layers, how do you manage at the infrastructure layer? How do you apply the patches? For example, firewall, the Cisco or Juniper provides the patch. Who applies the patch? If it is operating system, Linux or Windows or whatever, who applies the patch? And applications anyway, it is the responsibility of the end user, except in the SaaS model, because you don't manage the application in the SaaS. So within the data backup and recovery, what are my data availability requirements? What are my recovery mechanisms? How quickly, there is a concept called recovery time objective and recovery point objective. Recovery point objective is that we talked of ransomware, I mentioned it, right? The incident has happened now. Up to what point in time I can recover the data? Just before the incident, I should be able to recover the data. If it is 1 minute now, 12:01 now, till 12 o'clock I may want the data. Otherwise, it is of useless, right? Recovery time objective is that how soon can I recover the data? I have the data in my backups, but how long will it take for me to restore the data and bring my applications? Okay, so RTO and RPO. So you have to define what are your data availability requirements, establish recovery requirements. This is what I said. If I lose the data in one region, there is a server crash, data is not available. So you have to, even in the cloud, you have to have all these things in place. You have to define, and how do you get it? I replicate the data into multiple regions. So if there is a problem from this region, I can immediately restore it from my backup or point the application to the other side. How do I handle incidents? Like I mentioned, right? If there is a ransomware attack, how do you publish? Because of your compliance requirements, how do you communicate to the government? How do you communicate to your end users? What is the incident that has happened? So you need to have standard policies and procedures in place. And data segregation and application, like I said, don't expose all the data to everybody. Using list privileges, need to know principles, restrict access to all these things. And data leakage is one of the common things in cloud, because the administrators can take backups, and then it's the probability or possibility could be less, but it is there. So these are some of the additional security things that you need to be knowing within the cloud, right? So this is the stage we talked about. You develop the design, code develop, build, package it as an application, test it, deploy it into production, it becomes operational, you manage it. So secrets management, like I said, what is my encryption key? There is a user data, I need to encrypt the data and then store it in the server. But how do I manage my encryption keys? Okay, how often do I change my encryption keys? You may not want to use the same encryption key, 128-bit key, because that may also over time, the hackers will come to know, because they identify the pattern. This is how the data gets stored, right? So secrets management is one side, and the best practice I said is client side key management. You supply the key along with the data so that the data gets encrypted and then stored. Okay, so the key doesn't go to the cloud. API management we talked of, throttling, how many requests per second, per hour, all those stuff. Privilege management, identity and access control. Okay, who are the users? Have I defined roles for the users? Okay, again, password policies. How often the password should be reset? What should be my password key length considerations? And containers and container, probably you might have heard of Dockers, right? So Dockers is more like I containerize my application so that it becomes easily deployable rather than a single application. Microservices we talked of, right? So every service I will containerize using Docker, deploy it using Terraform and other tools that I mentioned, right? So infrastructure as a code. As part of that, my every service will get containerized so that it can scale up, it can be easily deployed. So how do I manage all those things is also important. And finally, the serverless applications and security. Every cloud services provider today gives you an advantage of you just write the code. Okay, you don't say how many servers you will need, where it should be located. It is called serverless. For example, in AWS it is called a Lambda function. Just like a Python, you write a code. Okay, you just store the code in the cloud. Okay, if there is a, as the number of users increase and the number of servers has to be increased, it will invoke the Lambda function based on an event. Okay, if it is more than 100 users, you will do a configuration setting. Okay, then it will invoke the Lambda function. That Lambda function in turn will incorporate an infrastructure as a template. It will launch additional servers. Okay, so this is what I said. The moment you start with something, it will lead you to the another thing that will lead again to another point in time. So it will help you to learn more and more. End of the day, it's all the same thing. It works on certain principles called need to know, least privilege, CIA, confidentiality, integrity, availability, right? It's nothing else more than this. But you need to follow all these practices right from design stage itself. So this is what the DevSecOps principle, right? For example, the design stage. The design stage, you need to understand what are the threats to my applications, to my environment, to my users. Then you go with the development stage. Okay, how do you manage the keys? What are the controls that you need to have for your JIT commit and all those stuff? Then you go with the static and dynamic. First you go with the static source code. You develop the application, you do a static code analysis to find out any vulnerabilities, test it. Then you go through the dynamic application testing, which in the real world you pass some false data and find out whether the application works fine. Then you deploy, it becomes fully operational so that your end users are getting access to the application. And we talked of containers and logging and monitoring. Anything and everything should be logged, monitored, correct controls should be in place to find out. And this is the secure cloud architecture we talked, right? In cloud, what should be the architecture? We talked of AWS, GCP, what is it that they have? So this is something for you, right? From the career planning perspective. What is it? Okay. Every organization can easily find developers, interns, train them, give them tools and technologies, in IDEs, integrated development environment frame, whatever it is, it becomes easily available, right? But today, if you see the number of job openings, most of them are with the cybersecurity world because you don't have the skilled resources. See, availability is different, right? We can claim that we are a security person, security engineer, database engineer, network engineer, all those stuff. But today the demand, because this is a never ending story, right? Technology is going to continuously evolve. New technology, nobody would have thought of cloud. Like I said, from a 2 GB server to an app and a smartphone today having 1 terabyte of storage, nobody would have thought of. So technology is going to evolve at a much faster pace. But more than that, the malicious side of things will continue. Before something gets deployed, they know how to hack a system. So the demand for people with strong domain knowledge in cybersecurity there is a strong gap today, and it's going to increase only. It's not going to come down. So almost everything is hooked up to the internet today. Like I said, right from your baby monitor, healthcare systems to refrigerator, manufacturing systems, everything, trains. See, now you see the cameras and the signals and everything, right? So how do they detect in real time? The cameras probably could have been integrated with the system with the police or any other cyber crime, right? So you have more interconnected systems, meaning that there are more vulnerabilities. If there is a problem in the software that the camera system has, that vulnerability could be exploited, right? I can easily make use of that vulnerability and then eliminate my image also, right? If somebody does a car crash and I have access to the camera system, I can easily eliminate that footage, right? So as you integrate more, the more chances of vulnerability getting into the system. This one. So the ability to gain access to high security organizations, infrastructures has frightened, because you are integrating more and more systems. You are integrating with cloud. You are developing microservice architecture. You are containerizing. If there is a vulnerability in the Docker code, that's it, right? So and people are looking out for that vulnerability. That's what so the hackers are not worried about doing millions of retries. They are not bothered about it because they write a code. They are not manually doing it. They are writing code to check, hey, is this door open? Is this door open? That's all they do. Out of millions of tries, if they find one chance, that is good enough for them. But for you to protect, you have to take millions of efforts to protect your system. So that's where the skill sets, knowledge, experience, everything comes into picture. Okay, that's what. So recently you might have seen that, right? The Iranian nuclear power plant got hacked. Nobody can physically visit Iran. Accessing the power plant, the possibility is very, very remote. But still, those systems got hacked. Probably it could have, the blast could have happened in that nuclear power plant, and think of the damages that it could have caused. So that's what. So it has become so serious because we are relying more on technology. Everything, anything and everything relies on technology. If that one vulnerability, just a click of a button, that's it, right? So it's very, very important that we design and testing, and ultimately what are benefits of incorporating all those principles, policies, procedures, guidelines. These are things business gets that assurance, right? Hey, my team, my development team, my network team, my database team, everybody follows these principles, practices, standards, guidelines, so that my end users, my customers are in fact protected, right? Prevention of unauthorized user access, improved recovery time. Have I designed my systems to be fault resilient? Okay, cloud gives you advantage from that perspective. How quickly can I recover my systems? And end users, and from the compliance perspective, yes, we are adhering to the compliances. See, this is just again, for you to know. So if you know the enemy and know yourself, you need not fear the result of 100 battles. You have to know both, right? If you know yourself but not the enemy, for every victory gained, you will also suffer a defeat because you don't know how the other person will behave, right? If you know neither the enemy nor yourself, that's it. You are in every day. It becomes a daily battle, right? So this is what the cybersecurity is all about. So it's not just knowing that I have ensured my systems are safe. No, what the other person will do, that is more important, and accordingly will prepare. That's what the war is going to continue. The war is not for today. No, it is going to continue as technology works. As you deploy more technology, it's going to continue. And these are some of the references that I have probably made use of, and for you to know, NIST, SANS, OWASP, NIC is from India. So there are so many things, so many materials available in the internet. But don't get gloomed into switching over from this to that to that to that. That will not lead you anywhere. Take one thing, for example, just to say that if you want to understand access control, okay, what are the things I need to know? What is need to know? What is least privilege? What is the difference between these two? Which one is more important than the other? For example, access control, again we talked of discretionary access control, right? Mandatory access control, how these things are used in the organization. Okay, there are so many things which is way beyond for us to discuss in these 4 hours. But the moment you start somewhere, take it to the next level. Start slowly but steadily. Okay, that will help you understand the concepts. Even if you are on a fourth year, it is immaterial of that. But the knowledge that you gain by reading something, practice is something different, right? Today you may not have an opportunity to configure a firewall or a server, but today you could do everything in your laptop. There are open source tools available. Okay, web application vulnerability. You launch your Nessus, Wireshark. So just go and see what is Wireshark. Okay, how does it help capture network traffic? See what is what. Okay, you go to Google and search open ports in servers. It may give you where and all the servers available in the ports are open. You can try to access this. So knowledge gaining is upskilling is very important. And like I said, if you have any specific questions, please feel to ask me. But again, don't think, yes, day one I am going to become I have mentioned it in the first place itself. It's a steady progress that you build. You start your career as a developer. Don't worry about anything. What is it? That alone will lead you to the reaching the goal. Okay, but cybersecurity as a domain requires you to have skills in every portion of it: development, testing, networks, database, operations, management, business, knowing about the business, cloud. So it requires you to have skills. But then every cloud is the same. Like I said, it is called virtual private cloud in AWS. It is called virtual private cloud because it is a virtually available. You don't have your own data center. Within the data center, your own portion. It is like your room within that whole house, right? So concept is the same. So how does a virtual private cloud work? Whatever you do in the on-premises, you will also do the same thing. But then the infrastructure as service, platform as a service, software as a model. These are models within the cloud, right? So knowing the concepts is the first step. That itself is a good place to start, right? So within security domain, don't think, I don't know about the types of firewalls. I don't know about the web application firewall. I don't know about DDoS attack. If you want to understand about DDoS attack, everything is there in the Wikipedia itself, right? So you may want to understand how does DDoS work? What does it that they do to disrupt the normal functioning of a server, right? Every concept, once you know, then it will help you to build a story for yourself. Hey, this is how I start my application. Today I develop a one-page web application. Within that application, how do I find if there are any vulnerabilities? Then that will take you to the next stage. Oh, there is a password invalidation is there. I have not incorporated a password validation mechanism. Once you do that, then whether my testing tool, software as a static application security tool, how do I do that? Okay, how do I check? What is dynamic application testing? How do I do that? So the moment you list down all this stuff, you are learning and enriching yourself, right? Thank you all very much. Really appreciate taking time to be here, and I think it's been there for last 11 or 12 days. And